Always you can proceed for the Google Colab. You can search Google Colab. In that you can go for the Google Colab itself. Okay, this window will get opened. Okay, in this open Colab, new notebook. Open Colab is for existing file you need to open. New book is for new code you need to prepare. Okay, I will go for the new notebook. Okay, once it is new notebook is get opened, what you need to do? First, you have to rename that particular file. Okay, I will rename this. Today I am discussing with respect to the Lab-02 experiments. Okay, so that Lab-02 today date is 13/10/2023. Okay, given this dot .ipynb is the extension for this particular file to execute in Python. Keep this in mind. Don't forget about it. What is the extension for the Python file in case of Colab? That is ipynb. That you can remember. Okay. Once you did in this cell, you have to take your particular code. And many of them you have asked me that related to that execution by the use of your mobile phone. Okay, especially for the practice codes, what I discussed. Okay, among that, in mobile phone, which is not getting output towards the what? The execution of the some codes which ought to be belongs to that of particular if conditions, as well as the some values you are going to enter as the execution. Okay, or else the data you are giving as a input. Okay, for those things which will not getting the output. Okay, for example, this is if condition is there. Okay, we need to discuss that as entered value is a positive. Okay, I will go for run. Okay, once I click on run, I will get an input box. Okay, in that I have to give the input. Okay, once I entered here a value 10, in my system what I am doing, I am pressing enter, then it is executing. But in your mobile, the next button is not the enter for this execution. So that you are not getting output. So that you are getting that as a error. Keep this is in mind. Got my point? Wherever the particular type of programs are there, those are to be having its execution with the input value. Okay, those type of execution is not possible to execute it by the use of the mobile app. But the processor is to be there. If it is to be taken care with respect to that of enter, then their type of mobile you are getting the output. Okay, keep this is in mind. At the same time, this is also you are getting the error. Okay, here also what I am doing, I am entering the value 45. Okay, especially only related to these. Then remaining all you are getting output. Okay, wherever you are not going to give the input. Okay, this is what the previous whatever I did. Then remaining all you are getting the output. Kindly verify, get the output itself. Okay, don't neglect all type of programs you have to execute. Here in previous lab, I discussed with respect to the Lab-01 programs, especially for what? Cartesian plot, polar plot. Okay, now we can discuss with respect to the Lab-02. Okay, this is regarding to the finding a angle between polar curve and the curvature of the particular plot, then radius of the curvature. For the what? The given curve, what is to be considered. Okay, for that aim is what? To study the Python program that uses finding the angle between polar curve, curvature, and radius of the curvature of the given curve. Okay, this is our aim. What you are using? Okay, as in your class also I have discussed. Python you are using and the MATLAB you are using. Okay, if it is online based, you can proceed for the Colab online tool. Okay, if it is system installed, you can use the Jupyter. or else ideally or Visual Studio. Okay, whichever it is comfortable, you can proceed for it. Okay, whoever having the system with you. Then MATLAB, it is available with online. There is no necessity of the installation. Proceed with respect to the online execution. But I have not discussed with respect to this. Later we'll discuss in detail with respect to all the codes. That is not at all be a problem. Next, theory concept. What do you mean by the angle between the two polar curve? Okay, that is the angle between the radius vector and the tangent is itself is called as a angle between the two polar curve. Okay, that will be given by tan pi equal to r into d theta by dr. Okay, r is considered with respect to the radius. Then theta is considered with respect to the angle of displacement which is to be happen with respect to the polar curve. Polar curve is nothing but what? The plot is to be taken care and considered with respect to the 360-degree. That itself is called what? Polar curve. Okay, but when there will be a multiple number of the curvature equations are to be there. What I need to take? I need to take tan pi 1, then tan pi 2. Okay, then angle of that pi 1 and pi 2 difference vector will be taken into as a resultant angle between those two particular curve. Okay, that is what the angle between the two polar curves. Okay, then radius of the curvature. Okay, for this radius of the curvature, directly you can use this formula to get the answer. That is to be there in the form of the polar form. That is rho is equal to r square plus r1 square raised to power of 3 by 2 divided by r square plus 2r1 square minus r1 into r2. Okay, this is the formula for the what? The radius of the curvature. Then parametric curves. Whenever there will be a multiple of the differential equations are to be there, during the moment we can proceed for the determination of the curvature radius. Okay, that is rho is equal to x dash square, then y dash square raised to 3 by 2, then y double dash x dash minus x double dash y dash. What is this x dash? Okay, x dash is the first order differentiation. X double dash is what? Second order differentiation. Y dash is what? First order differentiation. Then y double dash is what? Second order differentiation. Those are the representation. Keep this is in mind. Okay, this is the formula which is to be utilized for the what? To make the determination of the radius of the curvature. Then here the syntax of the commands which are to be used, because whenever I need to draw a particular curvature or the polar curve, that to be defined with respect to the differential equations. To get that differential equation, I can use a command diff with two parentheses, that is the open bracket and the close bracket. Within that, I can define the function and its variable, what is to be present. Then according to that, I will get the output. Then derivative, I can use the derivative. Derivative expression, what is the reference variable? What it means expression? It is this SYNP expression to get unevaluated derivative is found. Some of the derivation equations are not to be made the manual evaluation. Then you can proceed for the system solution. During the moment you can use, that is by the use of the syntax SYMPY. Okay, that is what the command is to be utilized to make the evaluation point of view. Reference variable is nothing but the variable with respect to the which derivative is to be found. Okay, that itself is what? The reference variable. Returns. Whenever your evaluation is get completed for the particular derivative is to be present in a particular given expression, it has to return back to that of the previous. Okay. Then another one is do it. I need to get a particular evaluation that to be get completed, then that to be evaluated. Okay, that to be done by the use of the do it of x, because x is the some variable or the parameter to be utilized. Then simplify, because whenever I need to proceed for the solution, okay, then I can proceed for the what? Simplify the particular expression. If you are taken an example, y is equal to x square plus 2xy plus y square. This is an expression. For that expression, I need to simplify means I can use the command simplify with that expression. Then what I will get? I will get the solution for the same. It means that whatever the expression is to be required, that to be expressed in terms of the mathematical expression to be expressed here in order to get the simplified output. Then another one is display. Display is nothing but I need to get the particular output in the form of expression. Because of that reason, I can use the display a particular expression wants to be required. We can type that is in the form of sentence that to be displayed in the form of the expression wants to be defined. Because of that reason, you can use this type of command. Okay, this expression is nothing but it is the mathematical expression which needs to simplify what is to be required. Then syntax of the substitute. In some cases of the differential expression, I need to provide the substitutions which are to be required to make the mathematical evaluation. Because of that reason, I can use a library with respect to that syntax is maths underscore expression dot subs. Then open the bracket, define the variable and enter which substitute you are going to consider. Variable is nothing but whatever the variable or the expression is to be considered as a substitute. That itself is treated as what? Variable. Then second thing is what? The substitute. That is the variable or the expression which will become as a substitute. Whatever you are going to make the replacement. Return is what? After the completion of that expression, what is being presented. That to be treated with respect to the return. Okay, this is what the theoretical concept is to be required. Okay, hope you understood this. Now we can discuss with what? Python programs. Okay, among that first example is what? Find the angle between the curves. Find the angle between the curves r is equal to 4 1 plus cos t and another one is r is equal to 5 1 plus cos t. Okay, there will be two expressions are to be given. Okay, one I will consider that as a r1, then another one I will consider that as a r2 because these two are two different curves. One is the 5 that is 4 of 1 plus cos t, another one is 5 of 1 minus cos t. Okay, because these two are going to provide the polar curves itself. Okay, because of that reason, what we need to do? We need to make the evaluation of the angle between these two particular curves. Okay, because of that reason, we are going to use the Python library function. Okay, yes, I told there in the previous discussion. Okay, with respect to that, SYMPY is what whenever you are going to do the mathematical evaluation by the use of the differential equations. This moment I need to import this particular tool. Okay, that is SYMPY. Okay, this is what to be used for the purpose of the derivative functionality evaluation. Okay, that is to be required. Then what I need to do? I need to define the variables which are to be required to be represented as a symbols. What I need to define? What are the symbols are to be there? One is R. I will take okay as the radius of that particular curve is to be presented, and T is the time variance to make that order of the differentiation with respect to the particular expressions what are to be defined. So that for that what I'm doing R comma T. Okay, these two are itself is what? The variable I am to define. Okay, these are to be get considered with respect to the symbols as represented as R and T. Okay, then second, I need to define the input of the first and the second polar curve. First polar curve is what? That is 4, 1 plus cos t. Second is what? 5, 1 minus cos t. Okay, these two are my polar curves. Okay, so that R1 is equal to 4. Star is what? It is the multiplication function. Plus is what? This is the addition function. That is the operator. Okay, always you should not write directly t. You have to use the parenthesis cos of t. Okay, then 5 into 1 minus cos of t. Minus is what? The operator for the subtraction. Okay, then later what I need to do? I need to differentiate because t I have taken as a variable. Okay, so that I need to find the derivatives of these two expressions. One is what? The derivative with respect to the first function, then second function. Okay, that is R1 and R2. So that the derivative of R1, I am representing dR1 is equal to DIFF is what? It's the function of the evaluating of the differentiation. Differentiation of R1 I want. R1 is what? It is the what? The variable what you need to consider with respect to the expression. Okay, this expression is itself is what? R1. That is which will consider. T is what? This is the whatever the parameter you are going to differentiating with respect to that particular expression. Okay, with respect to t, I am making that differentiation. So that I have represented with respect to the t. Then second is derivative of R2. Then R2 expression and the t, what you are going to derive it. That is DIFF, then R2, comma t. Okay, here if you have made that expression, then you will get that particular output itself. Then calculate the values of T1 and T2. Okay, I need to get the T1 value. I need to get the T2 value. Okay, these are the what? The time variants are to be present at a particular instant of the time T1 and T2. That I have defining. T1 is equal to what? The whatever the expression you are going to get as R1 divided by the differential equation. Okay, it is the first order differentiation, whatever you did. Okay, if you divide it, then you will get T1 value. Then R2 divided by differentiation of that particular R2 expression. Then you will get the T2. Okay, I got T1, I got T2. What I need to do? I need to get the solution for it. So that I am using the solve command. What I need to get? The solution of the R1 and R2 with respect to that of the particular time t. Okay, to find the point of interaction between two curves. What is the point of interaction? For example, this is one curve. Okay, then this is another curve. If you are considered, okay, whatever this point of interaction is there, that I need to identify. Okay, because of that reason, I can use this command to get the solve. Okay, then what I need to define? Solve R1 minus R2, comma, with respect to the particular time t. Then substitute the value of the t with respect to the t1 and t2. Okay, now whatever the value t is to be there with respect to that value of the t1 and the value of the t2, I need to substitute. Because of that reason, I need to define again a command to get the substitute. Okay, I have discussed with respect to the substitute how you are going to define it. Because t1 I did my evaluation, t2 I did my evaluation. That I have to make the substitution with respect to the what? This particular expression, what I defined, Q. So that T1 dot substitute. T1 is this expression evaluation, R1 divided by dR1 dot substitute of the what? The particular time T as the floats of Q of 1. Okay, which will make the evaluation of the T1 what is to be present. Okay, to consider that whatever the Q is to be present at the particular instant of the value 1. Because Q this value. at instant of 1. What is that value? That float number which will take. The float is nothing but it is the decimal number which to be raised because of that particular evaluation. Okay, that I will take as a W1. W1 with respect to the T1 substitute. Okay, W2 is equal to T2 substitute of the particular time variant as a float number of this particular Q was to be defined and was to be solved. Okay, later what I need to do? I need to find that is angle. Okay, because of that reason, I need to find the inverse of tan. Because tan pi 1, tan pi 2, but the pi option is not there. So that what I defined W1, W2. Okay, here I had to get the particular angle of the whatever the curvatures are to be present with respect to the particular curve. Here, tan pi. What I want? Pi 1 I want, pi 2 I want. When there will be a presence of the two curves are to be present. What I defined here? I defined that as W1 and W2. W1 with respect to the what? R1. W2 with respect to the what? R2. Okay, then I need that is pi 1. But pi option is not there to enter here. So that I had taken as a variable that is y1 and y2. Okay, A of tan means tan inverse. Okay, if you return tan pi, okay, tan inverse, okay, of a particular value. Okay, this I can represent tan of pi. Okay, but this how I have to write? A tan whatever the variable is to be present. Okay, that is what it is. This is the syntax. A tan is stand for tan inverse. Inverse functionality of the trigonometric functions. A tan of what? W1. I got W1 expression, W2 expression. Okay, what I'm writing on screen is visible now. Raise your hand. Okay, thank you. Okay, that is y1 is equal to A tan W1. I want the inverse value of this W1 value what you evaluated. Then y2 is what? A tan W2. Okay, corresponds that I will get the value. Some of them you are getting the error with respect to the syntax. Here W1 variable is defined as small letter w and 1. If you are typed capital W, then 1. You won't get output. You will get the error. So that you concentrate on that variables what you are defining. Okay, y1, then y2 corresponds to the tan inverse of w1, tan inverse of w2. Then later what I need to get? I need to get that is the absolute value of what? Y1 minus y2. So that w is equal to absolute value of y1 minus y2. Okay, after this evaluation, I need to get this output now. What is this W? So that print the result. Angle between the curves in radians. Okay, whatever is to be there in the form of the radians. Okay, so that the percentage of 0.3 F because the float what is to be there now, we are going to make that evaluation with respect to that of the variation happen with respect to that of the 0.3 variation. Then that percentile value will be represented as a particular value that to be taken as a W because which will have the multiple values. For example, whatever the value you are going to get 2, 3, 6, 7, 8, 9, 10, 2, 6. The lengthiest evaluation will be there. Okay, we need to precise this, then we need to get the prescribed that output. Because of that reason, I can use this functionality. The whatever the floating points are to be presented, that to be considered with respect to that variation of that particular value to be get considered. Okay, according to that, I will get that particular output itself. Okay, this is what the explanation for. This is first code. You have to get open your Colab, rename the file. Okay, once you renamed this file, what you need to do? You need to take a cell. In that, you have to type the code. Okay. Instead of that, what I will do, I will take my code. Okay, this one. Okay, this code I will execute with respect to that particular output. Okay, in your mobile, no, not necessary to type this commands, because these commands we are defined. You need to understand what the functionalities are to be defined below here. What it will does, its execution. Getting my point. Okay, import of this SYMP, we are defined this import star. If the star is not there, you will get error. Keep this is in mind. Okay, so that the properly you can define your the functionality according to your requirement. The whatever the value you are going to get, that will be get displayed here. Okay, for this expression, R1 is equal to this, that is for 1 plus cos t, R2 is equal to 5, 1 minus cos t. For this, I had to make the evaluation of the radius. Once you type this code, okay, then you will execute, then you will get the output. Okay, it will take a timer because the background connectivity, then execution, then taking that value. The angle of that particular two curves are to be get present and connected together is of 1.571. Okay, this is how you need to write a code to make the evaluation of the angle between the two curves. Any doubt for this execution? Hope you are understanding. This is how to execute. Here also there is no input I am not giving. Okay, in your mobile also, hope so you will get output. Okay, I will execute the same once again, then I will save that link to you. Okay, then second. Okay, here, same code, instead of this expression. Okay, we have defined the another expression. Okay, here R is equal to 4 cos t, then R is equal to 5 sin t. But what I need to do, I have to take this as R1, I will take this as R2. Okay, because R is the inbuilt variable who's to be already present. Those are itself is acting as a keywords. Those keywords are cannot be used as a variable to define your, especially in case of any programming as a variable. Okay, just have calling the symbols with the import of that particular SYMPY. Okay, that is the library to execute the derivative functionality. R1 I am defining the expression. Then I am getting the first order differential expression for R1 and R2. Then calculating the T1 and T2, that is dividing the R1 by differential equation of the R1, then R2 divided by the differential expression of the R2. Then I am solving that as a give in order to get the R1 and R2 interaction. Then later I need to get what? The particular value of the W1, W2 for the particular time period of T. After that, I need to make the inverse value. Okay, that is A tan of W1, then A tan of W2. Then I'm going to make the absolute evaluation of that particular angle. This W is itself is what? Your result. That I'm taking as a particular float in order to get that output. Okay, this is what the statement is to be required to make the evaluation for the consideration point of view. Okay, this is the what? Your second code. What I need to do? I have to go to Google Colab. Once I executed it, you can see here code. Okay, I can click on this code. I will get new cell. I got new cell. Okay, in this new cell, you have to type this second program. Okay, I will take the second program. This is my second code. Then I will type. Okay, once I typed, which will be present. Okay, you can remember whatever the hash lines are there. These are the comments. No need to type during your execution. Okay, if these lines are also be not there, na, you will get the output. That also I will execute and I will show. Okay, I will show the output itself. 1 minute. Okay, to calculate the R1, R2. Okay, once you did all these things, I will get. The comments are not required to type. Only these commands you type, which won't take much time. Easily you can type, but don't copy paste. Okay, try to type by yourself, then execute. Then you will understand the code what is to be presented, as well as you can capable to write by your own. That possibility is there. Otherwise, you will feel difficult to this execution. Copy pasting is no use. Okay, now I explained the complete code. Okay, then the same code what is to be present, if you are using for the different expression, easily you can made by yourself, then you can execute. That is my expectation. Execute, then you will get that output. Here you will get the angle 1.5708. Here float is defined 0.3 digits. How much I got here? 0.3 digits. 1.571. Here I defined the percentage of 0.4. How much I got here? 1.4708. Getting my point now? What I told, what you understood? 0.1570865. This is one number. Okay, if I return 0.3, float means 1.57 I will get. If I return 0.5 means 15708, I will get this output. Okay, this is the what, how you need to define your output, what you evaluated to be considering that as a floating parameter. That is the what, the decimal parameters which are to be present in the particular expressions. Hope you understood this. Is this clear? Anybody have any doubt regarding to this angle between the curve evaluation? Raise your hand if it is cleared. Okay, thanks for your response. Second is what? Curvature. I need to find the curvature. Okay, at a particular time t. For that, what they will do? Okay, they will give only one curve. Okay, that is r is equal to 4 of 1 plus cos t at t equal to pi by 2. Okay, this is my expression. For this, I need to find the radius of the curvature. What I need to define? I need to import SYMPY. Okay, this is the library for the evaluation by the use of Python on the differential expressions. Then you have to define T and R. Okay, T is what? The time functionality. R is what? The radius functionality. So that T is equal to symbol of T. Then R is equal to symbol of R. Okay, you have to represent that is with single quote that you can remember. Then define the polar curve. Okay, I have to define that polar curve. R is equal to 4 into 1 plus cos t. Okay, to find the first derivative. I want the first derivative with respect to the time t of the what? The particular r, what expression is to be defined. So that r1 is equal to derivative of r comma t dot do it. That is function. What is that do it? It has to does the function of the derivative evaluation on the expression R. Do it is the what? The functionality to be carry the differentiation on the expression is to be defined in previous variable as a R. That expression to be represented as R1 is equal to derivative of R comma T dot do it. Okay, these parentheses to be there. Okay, then similar to that R2. Okay, I got R1 because this is first order derivative. Second order derivative, I should not take for this R. What I need to take? I to take R1 because I got the first order differential equation here itself. Then that variable I have to use for again with respect to this derivative function. Then you have to make it do it because it has to does its function over that derivative evaluation. Okay, then I did this. Then calculation. Okay, yeah, already I have discussed the formula. What is to be there? Okay, here rho is equal to R square plus R1 square raised to 3 by 2. 3 by 2 is nothing but 1.5. R1 square plus 2R1 square plus 2 minus R into R2. Okay, according to that, the expression we are defining here. R square, okay, R1 square raised to 1.5. Okay, double star is what? Exponential representation. Okay, again, R square plus 2R1 square minus R into R2. Okay, this is the expression I defined. Then I'm getting with respect to that particular radius of that particular curve itself. Then substitute because T is what? The parameter. How much they are defined in expression? T equal to pi by 2. They are defined. So that I have to do the T as a substitute pi by 2. Okay, pi is what? The representation of that pi symbol. Okay, so that you will get pi as a rho. Rho 1 is equal to rho dot substitute. Okay, rho dot substitute is the library or the function which to be done to make that evaluation of that particular content what to be presented, which to be represented as a particular t value. T value is how much? Pi by 2. So that t comma pi by 2. Okay, later you got the R. That is rho 1. Okay, I want this value. That itself is what? The radius of that particular curvature. That will be you are getting. Okay, this is how you need to make the evaluation for the particular number of the content what is to be present. Okay, then what I will do? I will go to Google Chrome. I will add one more cell. In that cell, what I need to do? I need to type that particular code what I discussed. Okay, there is no necessity to type the commands, not at all be required. Now I explain this. This is what defining of the value of the T and the R1. Okay, this is what defining of the polar curve as a R. This is what the first derivative is to be done. That is the first derivation. This is what the second derivative of the first derivation what you did. Then to make the calculation of the what? The radius of the curvature. If you know the formula, how to utilize the arithmetic operators to write that expression in Python, then easily you can write this expression. Then substitute. I need to define this row as a row 1 so that I define that row to make that evaluation of the particular value at a t is equal to what? Pi by 2. Then I need to print this output. Okay, now I did this. Then there is no comment you can able to see here. Then I will run. I will get the output. Okay, 3.7712. Okay, here 3 is what it is? Digits. Okay, before that dot. Then 4 is what it is? After that decimal. Here we got this. It means that 999 dot 3415. This is the representation. Hope you are understanding. Okay, but I got here 3.717712 units. Okay, that is the what? The radius of the curvature. Hope you understood this. Okay, here without that comments I executed, you will get the output. This is enough. You type this one only. That is more than enough. But you have to type this first sentence, because what is that example you can understand. Okay, so that you can represent that expression. Okay, don't neglect it. Now I will take the same code, Control C, with that comments also I will execute. Okay, but because you need to know about it now, with that commands also it will execute or not. I got. Hope it's clear to everyone. What you need to type to execute your code. Now you can execute n number of what's to be required. Now typing is easy. Okay, so that these commands were expressed there to understand you from our manual. Hope it is clear. Now second, okay, that is a sine of nt. What it means? Sine inverse. Inverse functionality we got. Okay, corresponds that t is equal to pi by 2. N is what? It is the multiplication factor for the particular parameter. N is equal to 1. They are defined. For this, how many variables are there here? One is time, t, another one is r, radius. A is what? The function of the multiplying factor for this sine. Okay, then n is the what? The multiplying factor within that expression what's to be defined with respect to the t. Okay, these are all are what? Symbols. Okay, collectively also you can define, yes, separately also you can define one by one of your wish. There is no restriction. Okay, however it is possible, you can define. You will get the output itself. Okay, T, R, A, N are the symbols. Okay, because I defined. Okay, these are to be using my expression. Okay, I am defined means then it won't get any error. Then defining of the polar curve. A star sine of NT. Okay, this is the what? The multiplying operand. Okay, so that the expression to be written always within the parentheses. Keep this is in mind. Then what I need to do? I need to find the first derivative. R1 is equal to derivative of R comma T. Do it. Do it is what? The function of the making that derivation. Then find the second derivative of R with respect to the T. R2 is equal to what? The derivative of R1, because second order I want. Already I did the first derivative. That expression only I am using. Then I will proceed for with respect to the T, then proceeding for the do it functionality. Then calculate the row. You know the expression. Okay, that is R square plus R1 square raised to 1 by, that is 3 by 2, that can be written by 1.5. Then R square plus 2R1 square minus R into R2. Okay, then I will get the row value. But what I need to do? I need to make that evaluation for the particular value of the T is equal to pi by 2 and N is equal to 1. Then row 1 is equal to what? Row already I evaluated. For this, I need to substitute T value as pi by 2, N value as 1. Then I will get that particular curvature of the radius. Okay, but the whatever the values to be present for that particular curve have to be made the evaluation, it has to display. Because of that reason, display simplified value of R1. Simplifies the what? The function of the solution what's to be required to made after that simplification of the R1 value. Okay, this is what the code used to be there to get the radius of the curvature for this expression. Anything that is to be there, you can define that expression, you will get that output. Now I will do this. I will take this expression. Okay. Then I will go to the OLab. I will add new tab. Then I can type. Okay, this is my expression. Okay, that is R is equal to A sine NT at T equal to pi by 2 and N equal to 1. Okay, A sine theta it is. Like I told as a inverse, that is not inverse. A sine theta. Okay, that is N is the what? The multiplying factor within that T. Okay, because of that reason, A is one parameter, N is one parameter, R is one parameter, T is one parameter. Keep this is in mind. Don't get confused. Then I'm defining all these things. Then I have to get the value of what? That particular curvature radius. Okay, I will execute. Okay, once you did this, then you can execute. No need to type the comments. What are to be there here? Here, display simplify row 1. A square raised to 1.5 divided by 2a square. Okay, this is the expression. Because I defined as a, those are not having any values. A is not a number, it is the variable. I can enter anything. So that I got this expression. This is how you need to get the expression for the what? The particular simplified expression. Okay, display is used to make the particular expression itself. Hope you understood this. Okay, this is the radius of the curvature. Next, last one is that find the radius of the curvature x is equal to a cos t, y is equal to a sin t. Okay, these two are the expressions. Okay, for this, I need to find the radius of the curvature. What I need to do? I need to import SYMPY. What I need to do? I need to define. How many variables are there here? X is there, Y is there. Then R is to be required. I need to define because that to be required for the evaluation point of view. Then K. K is the what? The parameters to be required to consider when there will be multiple parameters are to be present. Then T, A, B, C, and alpha. Okay, all these are to be considering that as a required symbol in my code. Y is equal to what? Y is equal to A sine of t here. Y is equal to A into sine of t. X is equal to what? A into cos of t. X equal to A into cos of t. What I need to do? I need to find the first derivative that to be done with respect to the y corresponds to that of the x, dy upon dx. I need to make the differentiation with respect to that of the particular expression what is to be presented. Okay, because of that reason, what I'm doing, I'm defining a variable dy and dx is equal to what I need to do. I need to simplify these expressions x and y. So that I'm defining simplify what I want. Derivative of the y I want. Because of that reason, I'm defining derivative of y expression with respect to the what? With respect to the t. That is what? Derivative of y with respect to the t, do it. I got this differential expression with respect to the t. That is dy. I want dx. Dx is what? Derivative of x corresponding to the t will be get completed. Because of that reason, I used do it functionality. So that I will get the differentiation of x with respect to the t. So that I will get what? Dy upon dx. Then I got dy upon dx. But this backslash I should not use as a variable because what it is? It is the operator. So that dy dx I defined. Then what I want? I want rho. I need to get the curvature angle. Okay, because of that reason, okay, I am using simplify because I have the expression. Okay, that is dy dx. Okay, so that 1 plus dy dx square raised to 1.5. Then derivative of dy upon dx with respect to the t and derivative of x with respect to the t. Then I will get this particular radius of the curvature. This you have to remember the formula. If you remember this formula, you can type, then you can give the input, you will get the output. Okay, print that particular radius of the curvature. Okay, that itself is what? That is display rat simplify. Okay, this is also one of the functionality. Okay, when there will be derivative functions are to be there to simplify that one. Rat simplify. That is RATSIMP of what? Row. This is the row. For this expression, it has to make the evaluation, has to display that as the output. Then substitute of the value is what? T1 is equal to pi by 2. R1 is equal to 5. We are giving some values. Okay, to get that particular output, what is to be required for that particular expression? T1 is equal to what I am defining? Pi by 2. R1 is equal to what I am defining? 5. Then row 1 is equal to row dot substitute T. T value to be get substitute as a what? T1. Then row 2 is equal to row 1 dot substitute A as R. Then I will get that particular value itself. Okay, this is the substitute of the particular specific values to get that particular evaluation. Then print the radius of the curvature. R is equal to 5. Then T is equal to pi by 2. Okay, here I have defined pi by 2 and 5. Okay, for that I need to get that output. Okay, here backslash n is new line. It has to take to new line. Because of that reason, we can type backslash n. Then radius of the curvature at r is equal to 5, t equal to pi by 2 is simplify row 2 this value. This is your simplified radius of the curvature. Okay, then calculate the curvature. Okay, curvature is equal to 1 divided by row 2. To find the curvature is the reciprocal of that row itself is the what? The curvature of that particular curve what's to be defined. Curvature is equal to what? 1 divided by row 2. Print is equal to what? Backslash n. Curvature at a particular point 5 and pi by 2 is the float of curvature. I'm getting that curvature. Then whatever the floating decimal values are to be there to be get considered, that to be displayed as a output. Because of that reason, I use this print. Okay, this is the what? The third. Okay, whatever is to be present. Then I will take this code. Okay, then you have to add the new tab to type your code. Then I added new tab. What I need to do? I need to type the code. Type this code. What is to be there? There is no necessity of all these commands are to be required. Keep this is in mind. There is no necessity. Okay, without these comments, also you will get output. Okay, you should not type these things in your mobile because it will take a time. But only the codes what is to be required you type na, then easily you will get the output. This is more than enough. Simply you type this code, that is enough. Okay, whatever the hash lines are there, na, those are not at all be required. Okay, once you type this code, just you proceed for run cell or control enter. Then you will get the output. This is your radius of the curvature. Okay, for this expression, that is x is equal to a cos t, y is equal to sin t. Okay, a minus a of 1 divided by sin square t raised to 1.5 and sin cube t. Okay, this is the solution. But I need to define what? R is equal to some value, 5. then t is equal to pi by 2. Okay, then corresponds that the radius what I am getting that curvature minus 5. Okay, then curvature at that particular point phi and pi by 2 is minus 2. Okay, this is what how you need to get your output itself to make the evaluation for the radius of the curvature. Hope you are getting this. All of listening me, if you got my explanation, raise your hand. Okay, drop your hand. Now I'm keeping comments also. Okay, now I kept comment, then I will run. Here, I got output. Once again, I will run. You can see it is now displaying. Okay, this is what the third one. Okay, among that, the one more example is there. We'll complete this one last. Okay, find the curvature y is equal to a sine t of 3 by 2, then x equal to a cos t raised to 3 by 2. Okay, for this, I have to call the SYMPY, then defining all the variables what are to be required, then correspond to that what is the x expression, then y expression. Y is equal to what? A sine t raised to 3 by 2, x equal to a cos t 3 by 2. Find the differential expression dy upon dx. Then dy dx is equal to what? Simplify the differentiation of y with respect to the t and differentiation of x with respect to the t. Okay, do it is what? The functionality of the function to make the derivative function. Then calculate the rho. Okay, this is the expression. Okay, that is simplify 1 plus dy upon dx square raised to 1.5. Then derivative of dy upon dx with respect to the t. Then derivative of x with respect to the t. Then print the radius of the curvature. Okay, whatever is to be presented. For that reason, what I am using? I am using a function of rat simplify, RATSIMP of the row, because row I got. For this row, I need to display that particular output, what is to be required. Then later I need to do the substitute. Okay, I am defining T1 as pi by 4, R1 as 1. What is row 1? Row 1 is equal to row dot substitute of t comma t1. T to be replaced with respect to the t1. Then a is replaced with respect to the r1. Row 2 is equal to what? Row 1 dot substitute a comma r1. Then print the radius of the curvature at what? R is equal to 1, t is equal to pi by 4. Then backslash n is what? For new line. Okay, radius of the curvature at r is equal to 1, t is equal to pi by 4 is simplified value of this row 2. So that reason I have used the function simplify. Okay, row 2. Then you have to calculate the curvature. Curvature is what? Reciprocal of row 2, 1 divided by row 2. Then I have to display that output. For that reason, the float curvature I have used. Okay, these are what? How you need to make the evaluation with respect to that, the particular given expression. Once again, I will take this second example. Okay, what you need to do? You need to go to your Google Colab, add new tab to make your code to be typed. Type your code. Once you typed your code, okay, then you can proceed for your execution. Done your execution. Then you will get that output. Got it? This is the solution. Okay, 3, a cos of t raised to 3, then a sine of t raised to 3, then divided by a cos t raised to 3, then tan raised to 4 of t plus 1 raised to 1.5 sine square of t tan square of t divided by a sine of t raised to 1.5. Okay, radius of the curvature is what? R is equal to 1, t equal to pi by 4. For that value is minus 2.5. Okay, then the radius of whatever is to be there corresponds to that curvature at that particular point. t equal to 1, then pi by 4, that is radius is equal to 1, then t equal to pi by 4, that is 1 comma pi by 4 is minus 0.3964. This is how you need to define the output, what's to be required for your execution point of view. Hope it clear to everyone. Any doubt for this execution? Whatever till now I did this for lab 2. Hope you are getting this. Anybody is having any doubt, then you can ask. If it is cleared, raise your hand. Okay, remember display is what? To display your expression. This is your expression. Okay, to display this expression, we'll use this display command. Keep this is in mind. Don't get confused with respect to these instructions, what are to be there. Okay, hope it clear to everyone what I explained. Okay, only 6 codes are there. Okay, all these 6 code you have to execute. One with respect to the angle, another with respect to the curvature angle, then last with respect to the curvature. Okay, nothing else. You have to practice, you have to remember. Okay, otherwise you will feel difficult with respect to the subject as well as the execution point of view. Type the code by your own and execute. Then you will get the proper understanding corresponding to the code what's to be defined. First you type, then you write. Otherwise, if you are written, write it, type it, then get your output. That is to be required. It is to be mandatory to all to understand the concept what's to be required. Okay.